Hello, in this AQA GCSE Physics Higher Tier Paper 1 video from June 2018, we're going to go through question 9. As ever, press start and stop as you wish and take this at your own speed. Question 9. Figure 15 shows a coffee machine. The coffee machine uses an electric element to heat water. 9.1. The coffee machine has a metal case. Why would it be dangerous for a live wire of the electric cable to touch the metal case? So as ever in questions, look for clues, and the clue here is that it's a metal case. And you immediately need to think about electric shocks or the earth wire. So if something from inside the machine, so the live wire, touched the metal case, that means that all of the electricity would go to the outside of it, and then as soon as you touched it with your hand, that would then cause an electric shock and electrocute you going to the earth. So the answer for this one is there's a risk of an electric shock. In 9.2, the power output of the coffee machine is 2.53 kW. The mains potential difference is 230 V. Calculate the current in the coffee machine. So the first thing to note is we've got a K, and that means kilo. So 2.53, and to turn that into just watts, we need to multiply by 1,000. So anything with a kilo, we multiply by 1,000. So that then gives us 2,530 watts. And we know we've got the potential difference. So P equals 2,530, V equals 230, and we're trying to find the current. So we then need an equation. So the equation for this is power equals current multiplied by potential difference, or if we rearrange, so current equals power over potential difference. So it's 2,530 divided by 230, and if you put that into a calculator, that gives a current of 11 amps. For question 9.3, the coffee machine heats water from 20 to 90 degrees Celsius. The power output of the coffee machine is 2.53 kilowatts, as we just had, and the specific heat capacity of water is 4,200 joules per kilogram degrees C. Calculate the mass of water that the coffee machine can heat in 14 seconds. So it's worth 5 marks, so there's quite a lot to do. First of all, its specific heat capacity, and that's all about the change in temperature. So we've got a change in temperature of 70 degrees C, 90 minus 20. The power output, 2.53 kilowatts. Well, let's just remind ourselves that's 2,530 watts from the previous question. And we know the specific heat capacity, and that is symbol C. And we want to calculate the mass of the water. And the final thing we know is the time is 14 seconds. So the equation for specific heat capacity, energy equals mass times specific heat capacity times temperature change. Let's put in what we know. So we know the mass is what we want to try and find. That's then multiplied by 4,200, the specific heat capacity. And that's then multiplied by the 70, which is the temperature change. And that still equals the energy. So we have two unknowns. So because we want to try and find mass, let's focus on equations that we know for energy. Another equation for energy equals power multiplied by time. We've got a power, 2,530, and we've got a time of 14 seconds. So we can now calculate the energy, and that turns into 35420 joules. So let's put all the information in that we now have. 35420 equals the mass multiplied by 4,200 multiplied by 70. So if we rearrange the question mark, or we could just write the mass now, equals 35420, and that then needs to be divided by the 4,200 times the 70. So 4200 times 70, and that then in a calculator gives a mass of 0.12 kilograms. That now brings us to the end of question 9, and as ever, if you have any questions, please get back to me.